안녕하세요 여러분. 오늘부터 미분방정식에 대해서 공부를 해볼 예정입니다. 미분방정식은 일반적으로 풀기가 상당히 복잡하다고 볼 수 있어요. 미분방정식은 어떤 미분 개념과 방정식의 개념이 합쳐진 개념으로서 여러분들이 1학년 때 연립방정식의 해를 구하는 방법 등등등에 대해서 공부를 했습니다. 여기서는 미분과 관계된 어떤 방정식에 대한 해를 구하는 방법, 그리고 이를 이용해서 실생활 속에 어떤 문제를 해결할 수 있는지 이런 부분에 대해서 살펴볼 예정입니다. 일반적으로 미분방정식의 해를 구한다는 것은 상당히 어렵습니다. 따라서 우리는 미분방정식 중에서 특별히 좀 비교적 상당히 좀 단순한 형태인 오더 원인 미분방정식이라고 불리는 미분방정식의 풀이 방법에 초점을 맞춰서 공부를 할 예정입니다. Today we study differential equations. At first, we study what is differential equation and how to represent differential equation. Actually, differential equation is an equation given by a combination of differential and equality. And a differential equation can be expressed as an equation, and sometimes, as it is related with a function, we can represent it as a graph. For example, if y prime equals x squared plus y squared, we want to find the function y determined by x. So we want to find y equals x satisfying this condition. Such a problem is a differential equation because here is a differentiation and here is an equality. And we can also express this equation as a graph. For example, if x is y prime 0, 0 is equal to 0, so at this point the slope of the tangent line must be 0 and y prime 1, 0 is equal to 1. So at 1, 0, the slope of the tangent line is about 1 and y prime 1, 1 is equal to 2, and so if here is 1 and here is 1, then the slope of the tangent line is can be drawn in this way, and so on. In this way, we can express a differential equation as a graph. So we will study basically how to solve a differential equation by using some techniques, and we also study how to get an approximate solution by using a graph. And then we consider how to generate a differential equation. Actually, differential equation is involved with a function, and so we consider how to generate a new function from old function. A function is assumed to have a domain and codomain with the set of all real numbers. So in the set of real numbers, there are 4 operations: plus, minus, multiplication, and division. So we can generate a new function based on these 4 operations, and from functions we can get a function by using composition and inverse. So we will study about a relationship between differential equation and this operation and composition and inverse. And we can classify differential equation and by using the concept of order usually, and sometimes degree is involved with the calculation of differential equation. And then we will study how to solve a differential equation and how to apply it to solve some real world problem. Now let's start with the motivation for studying differential equation. Assume that y prime equals fx, then we want to find y in terms of x. Actually, it can be solved theoretically by integrating f. But this problem can be generalized. How can we generalize this problem? About this, we will study differential equation, and we study another motivation for studying differential equation. If t is a time parameter and let p be the population of some species at time t, for example, pt is the number of mosquitoes or number of bacteria at time t, then dp over dt, which means the ratio of change of the population with respect to t, is in many cases is proportional to phi. So this can be given as an equation like this one. And then we want to find the population of the species at time t. So how to find t, which is called the solution of the differential equation. So this is motivation for studying differential equation. And as I told you, it's usually very difficult and complicated to solve a differential equation. So we have mainly focused on differential equation of order 1. And so we will talk about what is the order of a differential equation and how to classify differential equation and so on. Our focus lies on differential equation of order 1. For example, more generally, we can consider a differential equation of y prime square plus x square y is equal to x square plus y double prime y prime plus sin x. This is an example of differential equation, but it's very difficult to find a solution of differential equation of this form. So we will start with some very simple example. There are two types of differential equation of order 1 dealt in our textbook. The first one is a separable one, and the second one is a linear differential equation. And we can also consider whether there exists initial condition or not. And then we will study how to solve these equations. Separable case, we use unification. We'll talk about what is unification later. And in the case of linear differential equation, we consider simplification. By using integrating factor. Which is denoted by Ix. This is called integrating factor. And so let's start with the definition of differential equation and what is the meaning of solving a differential equation and so on. We define a differential equation as an equation of differentiation and combined with the equality. Differential means and the order of differential equation denoted by a differential equation is simply denoted by dE usually. The order of a differential equation is the highest derivative in the equation. Solving a differential equation means finding all solution. A solution means a function satisfying the condition. If a differential equation is combined with some condition such that y0 equal y0, then such a condition is called an initial condition. Usually, if we solve a differential equation, there are infinitely many solutions. But if we give an initial condition like this form, then usually it has a unique solution. A differential equation with some initial condition is called an initial value problem. Let's consider some example of differential equation. For example, x squared y double prime plus x y prime this is the differential equation of order 2. Because we can find the y prime and the y double prime, so we have a differentiation, and here is an equality. So it is called a differential equation, and the highest order appearing in the differential equation is is y prime and here is y double prime. So the order of this differential equation is defined to be 2. And if we consider another example, let's say y prime equal sine x plus 1 multiplied by y, then we will solve this and we consider an initial value problem as following. We want to find the solution the initial condition y0 equal 2. Let's solve this problem. And you have not studied how to solve a differential equation, but in this case it's not so complicated, and so we can solve the problem. Since y prime is equal to sine x plus 1 multiplied by y, by dividing both sides, we have the following equation. Say y prime over y is equal to sine x plus 1. Why do we divide both sides by y? You should know the reason for dividing both sides with the term y later. And if we have this equation to remove, we want to find y, and so we should remove y prime. To remove y prime, we consider the inverse concept of differentiation. What is the inverse concept for differentiation? Yeah, it's integration. So by integrating both sides, we expect that we can remove the differentiation notation at here. So if we integrate both sides, then we can see that log the absolute value of y is minus cosine x plus x plus some constant. Then we can see that y is plus minus e to the c e to the minus cosine x plus x, and so this can be expressed as k times e to the minus cosine x plus x, where k is considered as the number plus minus e to the c. And so this is a solution for this differential equation. And the second problem, we want to find a solution with satisfying this condition. So as I told you, there are infinitely many solutions of this differential equation. But if we consider some initial value problem, then we can have a usually unique solution. Problem 1 we have already seen. Y is given as y equal k e to the minus cosine x plus x, and if we suppose that y0 is equal to 2, then by replacing x and y with 0 and 2 at here, then we can see that k is equal to twice of e, and so we can see that y is equal to 2 times of e to the negative cosine x plus x plus 1. So we have a unique solution satisfying this initial condition. This is an example of solving a differential equation. As the differential equation is simple, we can solve it, but if you try to solve such a kind of differential equation, you will feel, wow, it's too difficult to find some solution satisfying this condition, this differential equation. So we have studied some definition of the differential equation. One order means how to solve a differential equation for some specific case, and so we have also studied what is an initial condition and solving on initial value problem. So this is based on equation, and we can approach it to solve a differential equation by using some graph. It's usually difficult to draw a graph of a differential equation, so we consider just some specific case. Okay. In general, it's difficult to solve a differential equation just by using graph. And so we just consider a differential equation of the following form. If we have a differential equation given as y prime equal f of x, y, then we draw a small line segment the differentiation y prime means the slope of a tangent line. So we draw some several line segments with a slope. Since this is y prime, we draw some small line segments with the slope fxy, and it is called the direction field or slope field. By using direction field or slope field, we can get an approximate solution for the differential equation. In the direction field, the line segments give us information about the direction of a solution curve. Let's consider what this means by considering the following example. example, we assume that y prime is given as x squared plus y squared minus 1. And first, we want to sketch the direction field. And then we want to solve the equation with an initial condition. To sketch the direction field, we make up a table of y prime for each x, y. For example, if x is minus 2 and y is 0, then we can say that y prime is 3. And if x is minus 1 and y equals 0, then the value of y prime is 0. And in this case, y prime is minus 1. In this case, y prime is equal to 0. And in this case, y prime becomes 3. And in this case, from the equation, we can see that y prime is 4. In this case, y prime is 1, and so on. In this way, you can fill up a table like this one, and based on this such a kind of table, you can make up the direction field. For example, if you assume that here is a point 0, minus 1, minus 2, and 2, and so on. If x is minus 2 and y is 0, then y prime is 3. So we draw a small line segment whose slope is about 3. And if x is minus 1 and y equals 0, then the slope y prime is 0. So we draw a line segment whose slope is 0. And if x is 0, y is 0, then y prime is minus 1. So we draw a small line segment whose slope is about minus 1. In this case, the slope of the curve must be 0, and in this case, the slope of the curve must be 3. So in this way, you can make up a field of slopes. So if you draw a small line segment based on such a table, then you can get a direction field. And the second problem, we want to find a solution curve passing through the origin, then you may actually find a curve by connecting the small line segments naturally at here we have a slope 0, 0, and here is -1, here is about 1. For example, if x is -1 and y is about half, then the slope is some positive number. So we have by naturally connecting the small line segments appearing in the first step, we may get a solution curve like this one. But usually it takes too much time to make up direction field, and it's also not so easy to find a solution curve of this form. In particular, if the function is more and more complicated, then it may be very difficult to solve the problem just by using such a method. Anyway, in this way we can get a solution for some specific kind of differential equation, and then we will mainly study how to solve a differential equation of order 1. If the differential equation has order greater than or equal to 2, then it's more complicated, and I think you will study how to solve a differential equation of order greater than or equal to 2. And in this chapter, we mainly study on differential equation of order 1. And at first, we study what is separable differential equation and how to solve a separable differential equation. And then we will study what is linear differential equation and how to solve a linear differential equation. Okay. A differential equation of order 1, which can be expressed as this form, is called a separable differential equation. This means that y prime can be given as a multiplication of an equation of x and an equation of y. So this equation has only variable x, and this equation has only variable y. So we can separate the equation in the right side as a product of an equation of x and as an equation of y, and we can solve the separable differential equation as following. If dy over dx is dx fy, then in mathematics unification is important. So we similar properties. So here is y and here is y. So we collect terms with y and we collect terms with x. Then we can see that hy dy is equal to gx dx, where hy is 1 over fy. And by integrating both sides, we can get a solution for such a kind of differential equation. More concretely, let's solve a separable differential equation as following. We want to solve dy over dx is given as x squared over y squared. With an initial condition y0 is 2. Okay. So we collect terms which have y and which have x respectively. Then y squared dy is equal to x squared dx, and by integrating both sides, we have such an equation, and then we can see that this can be transformed in this way. Actually, you can have an equation of this form, but the integral constant may differ, so let's express in this way. Then by considering C2 minus C1, we can get an equation like this form. So such a process is omitted in this calculation. Okay, and then by multiplying 3 and taking cubic root, we have an equation of this form, where k is considered as 3 times of c. Then, if we consider the initial condition, k must be a. So we have a solution for the given differential equation as cubic root of x cubed plus a. Okay, so this is the solution for this differential equation. We have studied what is a separable differential equation and how to solve a separable differential equation. Then from now on, let's study what is a linear differential equation and how to solve a linear differential equation. simplest differentiation can be expressed as y prime equal to x, and in this case, y can be obtained by integrating to x. So this is differentiation because here is differentiation and here is inequality, and in this case, by integrating the right hand side, we can get a solution. And then we want to find the differential equation which can be transformed y prime equal qx. We want to find such a kind of a differential equation. So in transformation we use generator. So we should consider generators which is plus minus multiplication, division, composition, and inverse. And considering these operations, we have an answer. Say that y prime plus pxy is qx. So why this can be transformed in this form. For about this, we will consider the following. The differential equation given in this form is called a linear differential equation. And this linear differential equation can be transformed as y prime equal to x. We will check about this. There is no scale or no cubic, and so this is called a linear differential equation. And to solve a linear differential equation, we use a tool called an integrating factor, which is defined as it to the integral the coefficient of y px dx, and this is called the integrating factor. The linear differential equation. This is simply denoted as LDE sometimes, okay? So we have a question, why do we need integrating factor? Why do we define an integrating factor in this way?